language is a core part of human cognition. It's language that constructs thoughts. That's where thoughts come from.
Welcome to Closer to Truth Chats. Today I'm speaking with Noam Chomsky, the distinguished theoretical linguist, analytic philosopher, and cognitive scientist who is one of the most cited living scholars. Closer to Truth is presenting this four-part miniseries with Professor Chomsky. Part 3 focuses on the implications of Chomsky's linguistic theories, especially universal grammar, for human sentience, cognition, evolution, and uniqueness. Noam, let's start with how a universal grammar affects the understanding of human development. You've talked about how a baby learns language and the importance of a universal grammar.
Well, first of all, let's turn to some things that are now pretty well established by experiment. There have by now been careful statistical studies of the data available to a young child, 2 or 3-year-old child, mainly by Charles Yang, a cognitive scientist at the University of Pennsylvania. Careful analysis. He's shown that it's extremely sparse. Now, there are a lot of words, but the same words keep recurring over and over. There's a descriptive phenomenon known as Zipf's law, which is shows about the rank frequency distribution of words in a text. Turns out that some words like the or a appear many, many times. As you get to other words, they appear fewer times. Most words appear maybe once, in a long text. Well, that means the actual data available to a child may be many occurrences of words, but very few words, very few bigrams, pairs of repeated words, and so on. So the data is very sparse. Studies of language acquisition, the most exciting of them by Lila Gleitman, a friend and colleague who passed away a couple of weeks ago, great scientist. Her work and other work demonstrated that children have very impressive linguistic knowledge at a point where they can't exhibit it. So some of her early work back in the 60s had to do with what's called telegraphic speech. And there's a period in language development, a young child will only use what sounds like the way telegraphic speech works, only substantive words, like want, cookie, let's say, something like that. That's speech. So turns out, I won't go through the experiment, but it turns out that at that age, the child doesn't understand telegraphic speech. It only understands normal speech, meaning that in its mind, it already has the whole complex system. It's just not producing it. Turns out that the meanings of words, complex words, are learned with almost maybe 1 or 2 presentations. Somehow it's all in the mind and just comes out when it's triggered. Things like, again, structure dependence, the principle that I mentioned, the fact that all operations in all languages keep only to the abstract structure that the mind creates and ignores all of the evidence that is presented, linear order. So from the earliest testable age on through life, we ignore 100% of what we hear and use only abstract structures that our mind creates. Absolutely no way for this to be learned. It's inconceivable, literally inconceivable. And that means it's just built in. We now have an understanding of why that actually is forced by the simplest computational operation. If you go back to what I said about evolution, some disruptive change takes place, Mother Nature figures out the simplest way of reconstructing the system, accommodating that disruption. That seems to be what happened with language. As soon as the disruption took place, the system was created in the simplest possible terms that yields automatically such things as structure preservation, the other kinds of phenomena I've been describing. It must also be the explanation for the meanings of words, but there it's mysterious. We don't know how. Just know that it happened, but don't know how. Well, what does that tell us about human cognition? It tells us that probably a very substantial language is a core part of human cognition. It's language that constructs thoughts. That's where thoughts come from. Any kind of thought that we can comprehend, at least, is simply basically language. It's what language produces. So that's a core part of our nature. That's what distinguishes us from other species, thought and language. And these core parts of our nature seem to be quite substantially simply built into our nature, shared by all humans, developing through triggering by environmental stimuli, can lead to what look to very different outcomes. But as soon as we look more deeply, we find that these are surfaced variations based on fundamental similarities. Well, I think that tells us a good bit about one of the few parts of human cognitive capacity that we know anything about the Jerry Fodor, great philosopher, cognitive scientist, once joked that cognitive science is the study of vision and language. It's not far from the truth. Language is one big part of it. Vision is another big part of it. Vision works the same way. It turns out that by now it's understood that very limited stimulation is necessary. If an infant, we don't experiment with infants, but humans have the same visual system as other mammals. So with other mammals, cats, monkeys, you can show that if you don't present pattern stimulation in the early days of life, the visual system won't function. It has to be set off by the right kinds of stimulation. And if you modify the kinds of stimulation, say horizontal lines instead of vertical lines, it'll affect the way the visual system develops. That's pretty much like language. It's not the first weeks of life, it's the first year or two of life. The basic system is set one or another way, and then it just grows out of what Mother Nature endowed us with. True of the visual system, it's true of ambulatory system, the way you walk and so on. It's true of language. It seems to be just the way organisms, it's true of other organisms that we know of. So that seems to be pretty much the way organisms develop. Now, there are plenty of differences. So we have a different culture than, say, the Bantu, who separated from other humans over 100,000 years ago. Different culture, but basically the same. If you take an infant from that culture and raise it in Boston, it'll go to Harvard and become a quantum physicist. Conversely, there doesn't seem to be any detectable cognitive difference. So there are a lot of things we learned from this.
In the 60, 65, going on 70 years since you've developed the ideas, particularly the universal grammar, neuroscience in particular, which was my original field, has mushroomed with ability to do functional NMRs, all different kinds of scanning devices, plasticity in neuroscience. So as you have seen the development of neuroscience over these decades, how do some of the structural concepts relate to the abstract ideas of hierarchical structural building and in the language system? Because your ideas with these kind of cognitive concepts, which has to be instantiated in brain tissue. So how has neuroscience affected or confirmed or questioned the cognitive ideas that you've had?
Well, first of all, let's recognize that the brain sciences are a very difficult field. First of all, because of the complexity of the brain, but also for ethical reasons. You cannot do the experiments that come to mind. You can't do invasive experiments with humans, okay? We know a lot about vision, but that's through invasive experiments with other animals, which have pretty much the same visual system. Can't do that with language because there's no other organism that has anything remotely like a language system. This is unique to humans. So comparative work is out. Direct invasive work is out. That means the kinds of research you can do are very restricted. So what you're talking about, which is real, sophisticated, significant, is basically imaging studies where you try to look at things like rate of blood flow in one or another part of the brain to see what's happening. And you cannot stick an electrode into the language areas of the brain and see what a particular neuron's doing. Just not, I mean, you can in principle, maybe if you're Mengele, you can do it, but ethical considerations block it. You can't raise a child in a controlled environment to see what would happen. Okay, if you could do that, you could learn a lot about development, but it's ruled out. So the first point is experimentation is extremely limited, both by complexity, but simply for ethical reasons. Still, things have been learned, and there are some interesting results. The most interesting result I know of actually has to do with structure dependence. The thing I mentioned, the fact that the rules of language don't pay any attention to what we hear, linear order, but only to abstract structures that the mind constructs. There's experimental work on this, very interesting. It's done under the design of Andrea Moro, Italian linguist who's a friend of ours, very good linguist. He designed experiments which were carried out by an advanced neuroscience group at Milan in Italy, where the design of the experiment is basically this. You have monolingual subjects, maybe speakers of German, and you develop invented languages, not real languages, invented ones with kind of like Jabberwocky, words that don't exist, and have two different kinds of inventive languages. One of them modeled on a language they don't know, maybe Japanese. The other using simple computational operations on linear order. So what will be interpreted as negation takes the third word in a sentence and makes that the negative particle. Very simple computation. Okay, so give the subjects these two kinds of materials. what he found is that when you give them materials based on an existing language, the areas of the brain that are involved in language processing are all lighting up, they're working. When you give them the ones using simple computations like linear order, you get diffuse brain activity, meaning it's been being treated as a puzzle, not language. There's actually supporting psycholinguistic evidence. Neil Smith, British linguist, fine British linguist, also a friend, had been working for many years with a subject who he named Chris. It's a person who has extremely limited cognitive abilities, almost nothing, but fantastic linguistic capacities. You put a grammar book in front of him of some language he never heard of, pretty soon he knows the whole language, you know. He did pretty much the same experiments with Chris. Chris could do nothing with the puzzles, nothing, just blank stare. With the system modeled on an actual language, he just treated it like any other language. Well, all of this strongly suggests something, that there are brain areas specifically attuned to language, and they will pick out the structures and force us to operate the way I've described. We have plenty of other cognitive capacities. We can solve lots of puzzles, but they seem to be dissociated from language. Now, this fits with a lot of work that's been done from another direction. Eric Lenneberg, I mentioned earlier, a friend of mine in college, one of the 3 students who were disagreeing with everything when we were grad students at Harvard in the early 50s. He went on to found modern biology of language. And among the topics that he studied were what are called dissociations, people who have a high capacity in one area of cognition, but very little in some other area. So he began to study subjects with good language capacity, but poor cognitive capacities, and conversely, similar work. Now, that's been extended significantly since. One of the main people is Susan Curtis, cognitive scientist at San Diego University in California, has done extensive work on dissociations. And it has pretty much the same results. You find cognitive dissociations in both directions of many kinds. It looks as though language capacity is dissociated from other cognitive capacities. That's one of the reasons why very popular efforts to try to show that language developed out of general cognition, one reason why they always fail. These are just different capacities. So there is neuroscience, and this is one example, the best example I know of neuroscientific support for fundamental principles that emerge in the study of language itself and psychology of language. There are other things about hierarchic structure and so on, but it's very difficult to establish because the kinds of work you'd like to do, you just can't do.
What can a universal grammar tell us about the evolution of language? Your book with Robert Berwick, Why Only Us? Language and Evolution, really a superb book, deals with the questions. One of the issues that you have is the origin. To understand the evolution of language, you have to understand what is language, and the common idea that communication is the function of language, you say, derives from the mistaken belief that language somehow is an evolution of animal communication. You have this radical distinction between human language and systems of animal communication.
First of all, we should notice that the common phrase that you repeated, communication is the function of language. It's totally meaningless. Organic systems don't have a function, or they have many functions. So what's the function of the spine? Is it to help us stand up? Is it to accumulate calcium? Is it to develop white blood cells? Is it as a casing for a nerve? Actually, it's all of those things. Let's go back to evolution again. First, a disruption takes place, a mutation, symbiosis, some other thing, many things. Then comes the reconstruction stage. Nature tries to make the best of whatever happened. If it was a mutation, try to organize the new system in the best possible way. Then comes the winnowing stage, where among the things that have been created, the more adaptable ones survive, natural selection. But at the second stage, nature hasn't the slightest idea what the functions are going to be. It doesn't care about them. It's just finding the best design based on what's around. Now, that often leads to highly dysfunctional systems, because it may be that the best thing is not well designed for functions we'd like it to carry out. So, for example, during this last year, I've discovered that ears are highly dysfunctional for wearing masks when you have glasses and a hearing aid. It's a horrible pain in the neck. Nature made a terrible mistake and should have had different kind of ears. Well, same's true of the spine. And any engineer could engineer a better system than the spine. But the way it developed over time, this is the best that could be done. So talk about communication being the function of language is, first of all, meaning. Okay, because language just developed, it's used for many functions, for thinking, for reflection, for many kinds of actions. Among them is communication. But the idea that's hidden behind it is what you said, that language somehow evolved from animal communication systems. The evidence is overwhelming that that's not the case. Take even just what I've just discussed, the brief things I've discussed, like structure dependence. There's nothing remotely like it in any animal system. And take the meanings of words, the meaning of river, house, tree, anything. Nothing remotely like it in animal communication. In fact, in animal symbolic systems, the symbols actually do have associations with non-linguistic entities. So if you look at the cries of a monkey, various cries of, say, a vervet monkey, there'll be a cry that is made when leaves start moving in a certain way in a tree, and all the other monkeys run away. And we interpret that as a warning signal. What the monkey's doing, we don't know. But it's interpreted as a warning signal. Maybe there's an eagle up there and the monkeys run away. A hormonal change can lead to a call that basically means I'm hungry, Again, what's going on in the animal's mind, we don't know. But all animal communication systems, the symbols seem to be one associated with extramental entities, say, that a physicist could detect. Human language has nothing like that, totally different. The structural principles, the rules of combination, not even the remotest analog in other organisms.
So what are the implications of that for human uniqueness? You point out in the book that the primate brain in great apes or chimpanzees, it looks like it has a language readiness, but obviously, as you say, there is no language there. So what are the implications for human uniqueness?
Means it's just like every other system. Vision, say, There's visual readiness, which is built into mammalian visual systems. Its readiness doesn't show up unless it's stimulated. You don't trigger it, it degenerates. Okay. The way you stimulate it depends on how it develops. These are classic results in the study of vision. Language is the same. How did it develop? Well, we talk about this in the book you mentioned. Not too much is known, but there are some suggestions about, mainly based on work of German neuroscientist Angela Friederici has had some good ideas about how the brain, small changes in the brain, might have provided the principle of what's called recursive generation, the principle of that allows us to create an infinite number of structures, basically thoughts, from a finite number of symbols. It's called recursive generation. Her work shows how certain small changes in the brain might have led to that. Well, that would give us recursive generation. Nature takes over, does it in the simplest possible way, connects it somehow to our conceptual systems. You have language. Okay. In fact, many different languages, depending on how it's externalized in sound, or mostly in sound, sign. Looks like pretty much like that's what pretty much happened. Now, this is almost nobody in the field of evolution of language believes this. Almost everybody believes it must have been by a slow, small process of natural selection. But in my view, as I've said, I think that's simply based on a misunderstanding of the theory of evolution, concepts that were held 40 or 50 years ago, but have long been abandoned, and a failure to bother to look at the nature of language. If you want to study the evolution of any system, whatever it is, E. coli, anything, you first have to identify the phenotype. You have to say, what's the nature of the system that I'm interested in? You don't do that, you can't look at its evolution by definition. Well, much of the field doesn't look at the phenotype and is distorted by a misunderstanding of the theory of evolution. But if we extricate ourselves from these flaws, I think a relatively clear picture emerges of what might have happened with plenty of gaps to fill.
Noam, I want to ask you about consciousness. Consciousness is a core part of Closer to Truth, and we examine it from all aspects, the neuroscience, sure, but eliminative materialism, conscious doesn't even exist, neuroscience mechanisms, we deal with panpsychism, even to idealism. What could the language, and particularly your understanding of language and human uniqueness, contribute to the fierce debate in philosophy of mind about the deep nature of consciousness, if anything?
I should say, first of all, that I'm not overly impressed by this ferocious debate, but we could talk about that. Actually, I think the basic answer to the debate was given by Bertrand Russell about a century ago. I've talked about it. Within philosophy, it's been developed particularly by Galen Strawson, very good young philosopher. I think he's put it very clearly, basically Russell's point. He said, there's essentially no problem of consciousness. We know what consciousness is. That's the thing we know most about. That's all of our lives. It's consciousness. We know more about that than anything. I can tell you exactly what I'm conscious of right now in great detail. Russell's point. What we don't know is what matter is. That's what's obscure. In fact, I've written extensively about this, but it's a long story. But there has been no concept of matter since Newton. Newton demolished a concept of matter that was the basis of modern science. It was called the mechanical philosophy, the idea that the world is a very elaborate machine. It's Galileo, Leibniz, Huygens, Newton, all Descartes, all adopted this. Newton demonstrated that it's not true. John Locke immediately, within a couple of years, understood the consequences and concluded that it follows that thinking must be a property of organized matter, whatever matter turns out to be. And what matter turns out to be, we don't know. I mean, science keeps changing and moving, trying to discover what it is. So we know what consciousness is. We don't know what matter is. It's whatever the best theory of the world tells us. Then comes the problem of how to relate whatever the best theory of matter is with what consciousness is. It's basically Locke's problem. How to thinking is a property of organized matter. Let's figure out how it works. That's what we've been discussing. So what does language tell us about consciousness? I think it tells us something quite interesting. It tells us that almost all of the mental activity involved in language is inaccessible to consciousness. Everything I've discussed so far is inaccessible to consciousness. You can't introspect and discover that rules follow the principle of structure dependence. You can't introspect and find out why that he stole many books. He reads many books, means a voracious reader, but many books are read by him doesn't mean that. You can't introspect and figure out why how your mind is creating those two thoughts. But that's virtually all the use of language. Almost all of our use of language is just internal. What you and I are now doing, externalization, is a very small part of the use of language. Mostly we're thinking, we're reflecting, we haven't the slightest idea what's going on in there. We get little bits of fragments of it now and then reach consciousness. Well, all of that is unconscious. You have to study it pretty much the same way you study our second nervous system. Humans have two nervous systems. One of them's this one, the other one's this one. It's called the enteric nervous system. Huge, complex nervous system, huge number of neurons, almost all the properties of this one. It's what regulates our whole body. We're totally unconscious of it, except when we have a stomach ache and it says something's going wrong. But all of it has Alzheimer's, it has Parkinson's. It's a huge nervous system, but we haven't the slightest awareness of it, except occasionally stomach ache. Pretty much the same is true of our main nerve, the nervous system that's up here. We don't know what's going on inside it. We can't introspect. We have to study it from the outside, basically. And when we can learn about it, we've been talking about some of the ways you can learn about it. It leaves plenty of mysteries. I think what it tells us about consciousness is that consciousness is a pretty superficial part of human thought and cognition. Bits and pieces come out from what's going on in there, and there's not much more. I should mention that the history of the study of consciousness is interesting. There's good scholarly work on it. Best work is by Udo Thiel, good historian and philosopher. He's pointed out that the study of consciousness in the modern sense is a very modern obsession. There wasn't much talk of consciousness in the history of philosophy until pretty much the 17th century. And then the parts of consciousness that were discussed were consciousness of the inner workings of our mind, not qualia, what it feels like to see the color red, That's a modern thing. Pretty much 20th century. It's become a lead topic of philosophy, I think, in mistaken ways. The right way to look at it, I think, is Russell, Strawson, the way I've just been talking about. But what language tells us, I think, is most of what's going on in our mental lives is inaccessible to consciousness.
So there are really two questions here. One is the relationship between what we are conscious of versus all the other things going on in our mind that are subconscious. Language is a spectacular example. And of course, the autonomic system we have really no access to, and happily so. The other question, though, is on qualia, about why can we as embodied creatures have this scent of inner experience, felt experience? The two questions are separate. Maybe they're related. I appreciate your response to the first question in terms of relationship between, in language, that most things are subconscious, that we have no access to whatsoever. But what are your feelings about qualia? Galen Strawson, who was on Closer to Truth, good friend, we communicate. He has a kind of a panpsychic view of the world, that consciousness is everywhere. Russell had kind of a monism that I'm not sure I completely understand. What is your deep sense?
Why not ask a deeper question about Locke's suggestion? What's the relation between whatever the brain is constituted of and thinking?
Right.
That's a much more profound question. Well, it's a hard question. Most questions are hard. One question, which is, in my view, much less profound, is the one that philosophers are obsessed with. What's the basis in organized matter for perceiving the color red? Not for perceiving it, that we understand very well. Theory of how red is perceived is pretty well understood. But what it feels like to see red, we're probably never going to get an answer to that. Well, I expect to get an answer. So we know what we feel like. We can't describe it. Can you describe what you feel like when you see red? I can't. I mean, there's a lot of talk about, a lot of work was stimulated by Thomas Nagel's book on what it's like to be a bat. He argued persuasively that we can't really know what it's like to be a bat. Can we know what it's like to be a human being? Can you say what it's like to be you? I can't say what it's like to be me. I mean, I somehow experience what it's like to be me, but I can't convey it to you. Maybe somebody can write a poem about it, or write a novel. You read novels, it's sort of good literature, sort of gives you some insight into it. But do we expect to get a scientific answer to what it's like to feel, what it feels like to see the color red? I don't see any reason to believe it.
What I can say, Noam, is what it feels like to have this conversation with you is just wonderful. I'm sorry we're probably out of time, but that inner feeling in my consciousness is this has been a great experience for me. So thank you very much. Next, in part 4 of Closer to Truth's 4-part interview of Professor Noam Chomsky, we discuss his thoughts, opinions, and reflections on Closer to Truth's themes and big questions. Thank you for watching. If you like this video, please like and comment below. You can support Closer to Truth by subscribing.